what is sound? So everyone knows sound, but what is it like physically? So imagine you have a vibrating membrane, like a speaker membrane. So it vibrates, it oscillates, and then the air particles beside that, they get more or less pressure. So the air pressure rises and decreases. So you have fluctuations in the air pressure. That's what we call sound pressure. And these sound pressure fluctuations, they propagate through the air, for example, but also through solid bodies or through liquids. And when they enter the ear, our eardrums begin to vibrate as well. And these vibrations are then forwarded to the ossicles and then the inner ear. So that's where the vibrations of the sound are transformed into electrical impulses, which are then led to the brain, and that's how we hear, finally. The lowest sound pressure that we are able to hear is very, very, very tiny. If we transform this into movement of the air particles, then we can hear the movement of air particles which has the size of 10 to the minus 10 meters. That's the size of an atom. So these vibrations are then transformed, as I said, to electrical impulses, and we can hear this. So this is what we call the hearing threshold. So we are just able to hear some very, very faint sound. On the other side of the spectrum, we have the pressure which is much, much higher, and also movements of the air particles which are much higher. Imagine you are in a loud concert, big speakers, and you can actually feel and you can see your shirt vibrating and your trousers vibrating. So this is a huge range. It's a huge range we have to process. So the sound pressure between the hearing threshold and the other end where it's starting to hurt, it's 1 million times higher. So this is it's a huge range. That's why physicists said, well, it's kind of impractical to talk about sound pressure in terms of Newton per square meter or something, because the range is so huge. That's why the sound pressure normally is given in decibels. So what is done is that the log of the sound pressure is taken, and the log has some funny characteristics. For example, the log of 1 is 0, and the log of 10 is 1, and the log of 100 is 2, and the log of 1000 is 3, and the log of 10,000 is 4, and so forth. So you see that a big range between a very small value and a very big value is kind of compressed. And this is much more practical to use log values. And that's what we do with the sound pressure level. Sound pressure level means decibel values, log values. And so the range of hearing between threshold is at 0 decibels. 0 dB doesn't mean there's no sound pressure at all, but it means we have that sound pressure we need just to hear it, just at the hearing threshold. So this is 0 dB. And at the other end of the scale, we have about like 100 decibels or 120 decibels. At 100 decibels, it really starts to get very annoying, the sound. It's very loud. You want to like close your ears. And at 120 decibels, it really starts to hurt. It's painful. So this is then the scale between 0 and 120. This is much more useful and much more practical than talking about a range of 1 million or more.